My name is Arti Raju. I'm a principal architect with AWS. I've been working on this project for the past 3 years. You guys had a lot of VMware information since this morning, a lot of roadmap options and storage networking and migration options. We're going to take a 180-degree switch because as we talk to customers about the solution, we've been talking to these customers, some of these early access customers, and one thing they ask us is, hey, we also have a lot of AWS environments that we run. How do we seamlessly connect our VMware cloud on AWS that you guys provide to the native AWS environments that we run today? And how many of you are actually familiar with the AWS networking and the AWS services, at least to a 100, 200 level? Perfect. So I don't have to dive deep on anything. Traditionally, the way AWS worked, it's from a networking perspective, it's a very flat networking. We have this construct called a VPC, which is a virtual private cloud. Customers could go spin up a VPC and specify a network for it. So it's a layer 3 networking. We don't do any layer 2 networking in AWS, at least from a customer-facing perspective. So when we partnered with VMware, I think one thing that was challenging for us is, hey, how do we now interconnect this VMware cloud on AWS that also does overlay networking? You heard from Humair this morning about the compute gateway and the management gateway and these overlay networks that NSX allows you to run. So that's difficult for us. So how did we kind of pave the way in terms of engineering to help combine both these environments to provide customers the same consistent operations? We'll start with Direct Connect. I'm not going to go into a lot of details because Humair covered a lot of this. But the first one is from connecting from customers on-prem into VMware Cloud on AWS. Traditionally, Direct Connect, how it works is we just propagate the VPC CIDR block back to customers on-prem using BGP. So let's say a VPC CIDR block is a 10.0/16 network. It's just a private connection. We propagate that network back to customers on-prem, and customers propagate their network back to us. So you have this layer 3 connection between both these environments. With VMware Cloud on AWS, that was a challenge because Direct Connect doesn't propagate any of these overlay networks, the networks that customers run in terms of the logical networks, the workload VM networks. So we worked with VMware to enable propagation of all networks over Direct Connect. So it was announced sometime last year. Earlier, customers needed to have a VPN connection for the overlay networks, and the underlay networks was just using Direct Connect. From a connectivity perspective, and there was a lot of questions in the morning, and feel free to interrupt me. I'm probably the one person in this entire day with lesser number of slides because I'm hoping you guys ask a lot of questions. From a connectivity perspective across accounts, during the onboarding process, when a customer goes in and says, hey, I need a VMware Cloud on AWS cluster, even before specifying any of the management network, all that, the first thing that they're required to do is connect to an existing AWS account. They put in their account number of their AWS account, and what happens in the background is they execute a CloudFormation template. It's just a JSON file. And in the CloudFormation template, what happens is they also create an IAM role, an Identity Access Management role, with a policy attached to it. The policy has certain APIs. Basically, what customers doing is giving VMware a role-based access control model where VMware can log into that customer account that you see here to perform certain operations. What this helps us do is actually connect these accounts because we don't want customers to go manually configure connection between these accounts. We wanted to automate the entire process. So what happens is, now you're familiar with the VMware Cloud on AWS cluster there. The T0 is the NSX T0 router that Humair talked about this morning. And this is a customer's owned AWS account. So when a SDDC is created, VMware actually creates 17 elastic network interfaces in a subnet that customer chooses. For simplicity, I'm showing 4 here because I have 4-node cluster. But there's 17 ENIs that customers can actually see in their AWS account. So if I log into my AWS account and go under my EC2 and go under ENIs, I'll actually see 17 ENIs that are tagged with VMware Cloud on AWS with a do not delete tag prefaced to it because you never know what customers do. They'll go in, randomly pick ENIs. It's like, what's this ENI in my account, and delete it. It's happened to us. So we have a do not delete tag prefaced with it. So these ENIs are created. And then I talked about this manage policy that the customer gives VMware access to. What then happens is VMware assumes a role inside this account and then attaches these ENIs to the ESXi host running in the VMware cloud on AWS. Taking a step back, if I try to do this in my AWS account, if I have 2 AWS accounts, I create ENIs in one account and I try to attach it to EC2 instances running in another account, it will fail with a permission error because we don't natively support this with AWS. This was something we had to develop for VMware because customers told us like, hey, we want the same experience. Like, if you guys are telling us VMware Cloud on AWS is like another VPC, we want to connect like how we would connect normally within our VPC. So this ENI connectivity model provides that low latency, high bandwidth connection. So the ENI itself, it's a 25 gigs ENA adapter. So customers get that 25 gigs of aggregate bandwidth when they communicate between their VMware Cloud on AWS environment and their own any services that they run within their native AWS environment. Another thing that also happens in the background is the route tables. So within a VPC, there are multiple subnets. And assuming these ENIs are in subnet 1, what happens is, let's say there's a Redshift cluster, which is a data warehousing service that AWS provides. It resides in subnet 2. The route table of subnet 2 needs to know that, hey, any traffic that needs to go to my VMware Cloud on AWS actually needs to go to that one active ENI. So even though there's 4 ENIs here, only one of them is active at any given point. So VMware actually takes care of updating the route table for the customer. So if you look at the customer route table, you'll actually see a bunch of logical networks that customer owns on the customer workload network pointing to that ENI. A common question that comes up is hosts can fail. Failures can happen no matter if it's in the data center or in the cloud. We're all prone to failures. So if a host fails, a vSphere HA event kicks. As Humair mentioned, the NSX T0 is actually the edge is moved on to another host. And what happens is at that time, the ENI interface that's attached to host 2 needs to be active now, which means the route tables now needs to point to the second ENI. So from a customer's perspective, this is very transparent. They'll see an API call in their CloudTrail logs that shows their route table is updated to point towards the new ENI. And this is taken care of VMware. Customers don't have to go into their route table and say, hey, host has failed now, because again, that's what we want to take away from customers here. Host has failed now, and VMware automatically updates the route table. It's not only during host failures. If a customer adds a new logical network on the VMware Cloud on AWS side, which means the route table also needs to be updated with a new CIDR block now. So anytime a new network is added on the VMware Cloud on AWS, the route table is also updated. Questions? So
how long is connectivity expected to be interrupted, right? The host fails, the NSX edge fails, the ENI has to be remapped, it's brought back up. What is, and the route table is redirected, what is the estimated duration there?
Sure. So there's different failure scenarios here. Let's assume in the first question, the host itself fails, so the edge has to move to a new host, and then the route tables have to be updated here with the destination as the new elastic network interface. So typically in our testing, we've seen anywhere from like 3 to 4 minutes for the HA to for the entire network connectivity to resume back again.
So the route table, tell me a little bit more about the route table that you're manipulating. Is it
The main route table that is the default route table, and can I have other routes out of that subnet?
Very good question. The route table that's manipulated is by default the main route table, but we've seen customers who don't use the main route table. A lot of customers don't use the main route table, and what do they do if they don't use the main route table? What we've published right now is we have a Lambda script. Basically what the Lambda script does is it queries the main route table, and every time there's a change in the main route table, it goes and updates the other route tables that's associated with this entire VPC. What we're also trying to do in one of our roadmap items is try to see if we can have customers select which route tables they want VMware to update on a constant basis instead of just updating the main route table.
Yeah, if I may, I think that's a much better solution.
Now that's good feedback.
Yeah, just, designate a route table that's going to do this.
So how does this solution scale if a customer requires more connectivity between VMC on AWS and AWS then is provided by a single NSX edge and that single interface?
So as we scale, I think I have a slide on how we're going to scale as scaling both sides, right? Like scaling on the VMC side and scaling on the, what if customers want to connect to, like most of our enterprise customers have hundreds of VPCs, and this is a one-on-one solution right now. I'll get into the details of it just in a minute. From a VMware scaling perspective, I think Humair talked about it. We're also looking at, right now it's active and standby edges, but they're also looking at how to scale these edges as well. When we launched this service, we said, hey, you have this connectivity option using elastic network interfaces, so you can go integrate with your native AWS services. Funny enough, like interestingly, we thought customers would use a lot of like our platform level services. That didn't happen. They started with some of our base level services like storage. How does like integration with storage work? And I think there was a question earlier as well. Somebody asked about the VPC endpoints for S3 as well. Pretty straightforward. So assuming customers have VPC endpoints for S3 configured in their native VPC, and for folks not familiar, so S3 does it. So S3 is a storage service, and it does not reside within the VPC. It actually resides outside of the VPC. And if customers want to connect into that S3 bucket, it's an object-based store. They'd have to use an S3 endpoint, which provides a private connectivity method into that S3 object. What we also wanted to do is provide that same consistent operation with VMC, because now you have this connectivity established between this VPC and this VMware Cloud on AWS. On the VMware Cloud on AWS console, there's an option that says where you can enable or disable S3 access. What this ideally means is if I click enable, if S3 is enabled, any traffic from your compute network that needs to reach through an S3 in the same region will actually go through this cross-account ENI connectivity, then talk to this S3 endpoint and go outside. For folks familiar with AWS, I know what the next question is going to be. VPC actually drops traffic if it's not coming from its own CIDR block. So what we are doing in the backend is we're actually NATing all the traffic that's coming from any of the VMs to this ENI IP, and this ENI IP is nothing but it resides within the 10.2.0.0/16. So when S3 endpoint actually sees this traffic, it thinks, oh, it's coming from the local VPC. I can just send it to the Amazon S3 endpoint.
Is that only supported for S3 endpoint or any other endpoint services?
Jumping right into it. So endpoints, there's two types of endpoints today that AWS provides. One is gateway type endpoints. So S3 and Dynamo are services that fall under the gateway type endpoints. The other one is called our private link endpoint services. So I'll talk about how other services fall into the private link very shortly. Question?
Excuse me. I just read that EC2 is enabled. So can we connect a VIC, vSphere integration container with EC2?
Yes. So the question is, can I connect any environments running here to an EC2? Yes, that's enabled by default because that is provided by the standard connectivity. So if I have EC2 instances running within this VPC, that instance can talk to any network in the compute within your compute network. The only thing there is you want to make sure you have security groups on this side that allow that traffic, and vice versa on this side you have firewall rules on the NSX that allows that inbound and outbound traffic. There are also some customers who don't use S3 endpoint, and that's totally fine, right? We're not going to compel any customers to force their traffic out and go through this VPC. For customers who don't use S3 endpoints, they can use the internet gateway that's associated with this VMware Cloud on AWS to go out and talk to S3. Very cool fact about S3 is when you communicate between a VPC or any resources in a VPC to an S3 in the same region, there's actually no cost associated with it. So what we saw from customers is like a lot of backups of VMs going back and forth between S3 because there's no cost associated with it. And now you're storing, S3 is also pretty cheap in terms of storage. So you can back up all your VM data into S3. There's also a lot of other partner solutions like Commvault, Veeam, who has direct integrations with S3 as well.
Are there any cross-account IAM roles involved here, or is the restrictions really from the network side of things?
The restrictions are purely, if you look at the managed policy, it's published on our website. It's actually called Cross Network Operations. That's the name of the managed policy, and it's an AWS managed policy. So why we wanted to make it an AWS managed policy is we wanted to give customers the trust that VMware just cannot come in and modify any policy at any time. If VMware has to make any changes on the managed policy, there has to be a security review that goes to AWS. My team and the security team will audit if it's really necessary for that permission, and then the update goes into the managed policy. So customers are used to the AWS managed policies today, so we wanted to provide them the same trust that they have with AWS managed policies with the VMware policy as well. So these are the other services. So we do have interface type endpoints. That's the second type of endpoints AWS provides. What it means is any of these services that you see here, basically it's within the same VPC. I mentioned S3 and Dynamo like reside outside of the VPC. We also have other services that kind of reside within the VPC. And these are accessed using interface type endpoints. So any of these services that you see here, and these services are constantly updated as well, customers will be able to access it from their VMware Cloud on AWS environment into their VPC with any of these services. So if you think about it, right, think about an Amazon RDS database that the customer is running within their VPC. So Amazon RDS is ideally part of that VPC, which means its IP space is confined to this VPC. So which means any traffic from your compute network can actually talk to this VPC over this cross-account ENI. It's the same.
I guess, sorry, the point there is there's no NATing for that piece. Yeah.
For any of the interface type endpoints, there's no NAT required because the IP space is just within the VPC. For the gateway type endpoints, we only support S3 using cross-account ENI. DynamoDB is not yet supported. There's also other options. So similarly how RDS is, EFS is our file sharing, elastic file sharing service. We have both for Linux and Windows version. The Windows was very recently launched at reInvent last year. It's called FSX. So same thing. When I launch a file share, it actually creates interfaces inside that VPC. So it has IP address space inside that VPC. So I can mount a file share from here into this VM because it has this connectivity between both these environments.
Is there any is there any technical limitation to the services you have exposed via private link or these endpoints that won't work through AWS, the VMware Cloud and AWS piece, or anything that you support that can be one of your services that can be connected into a VPC can then be accessed by VMware Cloud and service? Okay.
As long as it's supported by as long as the service is supported by private link, it will be supported by VMware Cloud and AWS. We still have some services we are trying to get added into our private link portfolio, but most of our common services, like our services that were announced until like last year's reInvent, should be part of private link.
But that's a dependency whether you're using VMware Cloud and AWS or not.
It's even for native AWS customers.
Exactly. Okay.
I kind of did this demo. I just got back from the AWS Summit, Anaheim, Orange County Summit yesterday, and we did this demo there. If you kind of think about how this all fits in together, right? We're not asking VMware customers to go use AWS services. If they don't have to, that's completely fine, right? Depends on customers' use case. We also saw some customers running their entire web stack in this VMware Cloud on AWS. But one thing they told us is, hey, AWS provides a number of security services, DDoS mitigation, or web application firewall for that instance. How do we use these services in conjunction with our VMware Cloud on AWS? And that's pretty straightforward. As long as you have this connectivity between these two environments, you have the application load balancer that AWS launched. And earlier, the way load balancing worked in AWS is when you create a load balancer, the backends could only be EC2 instances. But a recent feature that we launched is IP target groups. What IP target group means is it doesn't necessarily have to be EC2 instances behind this ALB. It also can be private IP of other VMs as long as there's connectivity between these two environments. So in this example here, you'd see I would have added some of the VM networks behind my IP target groups that's actually running within my VMware Cloud on AWS. So incoming traffic can actually come into the DNS name of the ALB and then get routed and load balanced to the web application stack that you're running inside this network here. What it also means is now you have the flexibility to integrate with a DDoS mitigation service or a web application firewall. So if you think from a security perspective, if there's something, any security element that you think you're missing here that you want to get added with additional services, that is possible as well.
Is it meaningful that your IP target group shows 2 IPs in the same subnet in VMware?
It doesn't matter. I think I just picked the 2 because I wanted to show like both the blue environments here, but it could be across any logical network.
Okay.
There was a question on scale. I think Humair covered it as well. Like a common question that we get from our customers is like, hey, the cross-account ENI connectivity model is one-on-one, but most of our enterprise customers in AWS have several VPCs that they want to connect to. How do we do that today? So today, the option that we are providing is using a transit gateway. So from a transit gateway perspective, there's a couple of attachment models. One is a direct attachment into the transit gateway. There's no VPN connection or anything. It's basically attaching the VPC directly into the transit gateway. So if you look at this is all my customers' native VPCs, and these can be connected natively into the transit gateway. From a SDDC perspective, today the option that's available is we ask customers to create a VPN attachment into this transit gateway. The transit gateway is think of it as a virtual router on the AWS side. We just manage all the network traffic through it. And that was a pain point customers told us, because earlier they used to use like Cisco CSRs or Palo Alto appliances. And I mean, I've done Cisco like CSRs in the past, and it's not fun managing those devices. I've also had like bigger customers like really complain every day about those devices. So we kind of listened to that feedback from customers and launched this transit gateway feature. So at scale, if customers have multiple VPCs, we can actually go up to 5,000 attachments on a transit gateway. It really scales well. It's built on AWS's Hyperplane feature. So, and if you have multiple SDDCs, you can connect it as a VPN attachment. And direct connect attachment into transit gateway is not available today. We're releasing it really soon. So right now, if you have an on-prem environment that needs to communicate to transit gateway, it has to be through a VPN. But once direct connect comes in, it kind of like completes the picture where you have this 10 gig link or a 1 gig link from your on-prem environment that terminates here. And then it's just the transit gateway that takes care of like any-to-any communication. Ideally, where we want to get to is even get rid of this VPN connections. Nobody likes VPN as well. We want to just attach SDDC as a native attachment into the transit gateway. I think that was it.
I have a question. So the example that you showed previously, where you were leveraging Shield and WAF and all that kind of good stuff in the native VPC, can you do the same thing using the transit gateway? Or, yeah, so those are ENIs that you can attach to and do.
So you cannot attach or you cannot integrate WAF or Shield directly with the transit gateway itself, because think of transit gateway as only a bunch of ENIs. Mm-hmm. We still need the application load balancer running somewhere. So that could be like in a VPC, in a shared services VPC here. Mm-hmm. And then you can, if it's an external traffic, you have an application load balancer here. External traffic hits the ALB, and then it can communicate using the transit gateway and the VPN back to this network. But you still need that application load balancer because WAF and Shield integrates with the ALB itself.
Right, right. And those ENIs that are being shown, is it a single network interface to each SDDC from each VPC, or can you do
Is this one you're talking about?
Yeah, I was wondering, can you do active-active or active-passive into the transit gateway so you have redundancy?
Today, it is actually a single ENI. When you create a transit gateway and attach it to a VPC, we ask you, hey, which availability zones you want to connect. Well, which availability zones you want to have ENI. So we create an ENI in each availability zone.
Okay.
So yeah, it allows for that any-to-any connection. And this is a common use case that we're seeing from customers as we like work with them more on like integrating with AWS services. There's other resources that are available.
Someone was asking a question about failover, and it's a tricky question because there's different, I think like Karthi mentioned, there's different types of failovers. As you guys know, there's different type of failures that can happen. So we have an active and standby edge. And that edge I talked about is providing that external connectivity, that tier 0, to all the external world, including the VPC. So when the edge goes, and we've done some improvements here, and you'll keep seeing further improvements, but in general, when an edge goes down, like one of the failure scenarios is that edge goes down. Well, remember we have the standby running, and there's a detection mechanism there that's going to be fairly quickly. I mean, we have like a heartbeat, like at 1 second, it's like, so it's about 3 to 4 seconds failover, and then you have to update the table. So it'll be like updating the route tables takes another 4 seconds or so, like, because you have to update, then, there's a new ENI being used. So typically there for all the connectivity, you're going to see in the, seconds time range. It's not going to be, extensive. Now, there's different failure scenarios. So it could be like a host goes down. The host goes down. What happens is then we move that edge to another host. It becomes a standby, and then the standby takes over and becomes active. So that's still going to be, fairly within a second's time frame. Then, of course, there's also multi-AZ. So if there's an AZ failure, that's typically when you're going to see more, that could be within the minute time frame at that point. But other than that, you should typically see seconds. It takes about 4 seconds to update the route tables. We're calling APIs to do that. And multi-AZ, again, that's going to be a little bit more. At that case, the vCenter is also filling over, and that vCenter has to come up in that second AZ as well, right? So you're going to have other criteria there. So I just wanted to point that out. Like, we don't typically use like one, say, okay, here's a number for your failover. Depends on that failure scenario. So I wanted to just throw that out there.